Our lesson for today will be looking at Chemistry 1502. The topic for today is easy system. We'll be looking at lesson 101. Let us start. Other geometrical isomers can be specified by the easy system. This system can be used to specify the configuration about any carbon-carbon double bond by using a set of priority rules. Those set of rules were devised by three scientists, which is the first one is R.S. Khan, the second one is C.K. Ingold, and the third one is V. Prolog. Sometimes you would hear that instead of easy system, they would say use or name a particular or the following structure, or give the IUPAC to the following structure using the CIP system. This simply means it represents Khan, Ingold, and Prolog. Should know that is the same as the easy because these are the scientists that devised this particular system. Before we look at the set of these rules, the CIP, let us look at E and Z. Z is a derived letter from a German which means zusammen. But for the sake of mastering, we can say zusammen. And then E, I cannot really pronounce this name. I'll just write it down just to avoid error pronunciation. This simply means that opposite. And by the way, this means same. So if you've dealt with or you've watched the cis and trans isomer lesson video, then you'd know that Z can be associated with cis and then E can be associated with trans. When we talk about the E is when we have alkenes that have the groups of the highest priority on the opposite side. So we're looking at groups of highest priority which are opposite side, and then Z is when we have alkanes that have the same, the groups of the highest priority on the same side. Let us look at examples so that we can explain this in detail. Before we can look at examples, let us look at the CIP rules. We do have a number of rules, but I'll just choose the two rules which I believe they are very important. But in the next lesson video, we'll be looking at the remaining rules. So the first rule is that the priority, it depends on the atomic number. If we have, that is rule number one, the atomic number. If in a structure we have, let's say we have a bromine and we also have hydrogen, we should know that bromine will take priority number one because it has the higher atomic number compared to hydrogen. And then we look at chlorine. In this case, if we have these three, it simply means that the priority will change. Bromine has higher atomic number, so it will be 1. Chlorine has second highest, which will be 2, and then we have the least atomic number, which is hydrogen. And then should it happen that we compare, let's say, OH and CH3, in this case, we don't take the sum of the atomic numbers. No, we only look at the atomic number of the first element. And then oxygen, we know that comparing it with carbon, oxygen will take priority number 1 because it has higher atomic number, and then carbon will take priority number 2. This is the first rule that you should know. Let us look at the second rule. If you cannot set the priority based on the first element in a compound, suppose you have CH2 Cl and CH2OH. You can see that it is impossible to set the priority number based on the first carbons, the first elements, because they are the same. Looking at the atomic number of this element is the same as this one. So what you do, you go to the next one, you check. Since we still have the same, we go to the third one. Should it happen that we have different elements here, then it will be simple for you to assign the priority using those elements, only the second elements. In this case, we don't have them, we go to the third one. Now you can see that chlorine has higher atomic number compared to oxygen, not OH but oxygen. So in this case, priority will take this, and then second priority will be this one. Now let us jump straight to the examples. We are going to use this general structure to name whether it is an E or Z. So if we look at the first carbon, if higher priority group is on top, and then here we are going to have a lower. We look at the second carbon. If the higher, it's also here, and then the lower it's here. As you can see that this will be the Zusaim, which will be Z. Then if we have lower, higher, and lower here, higher priority, then this will be E. Let us look at the IUPAC name for this, and then we also include the easy system. Now looking at the longest chain, we can see that this will be the longest chain. Because remember that the double bond should be part of the longest chain. Then we cannot say this will be the longest chain because the double bond will not be part of the parent chain. So how many carbons do we have? We are going to start counting on the closest. So we have 1, 2, 3, 4, 5. The double bond is on carbon number 2, so we have 2 pentene. On carbon number 2, which is this one, we have chlorine, so we have 2 chlorine. And then on carbon number 3, we have methyl, which is this one, so we have 3 methyl. Now we are in position to combine these parts and generate an IUPAC name, but let us check if it is an Z or E. We start considering this carbon, so we can see that the priority, and in order for us to see this well, let us write it like this. So we compare chlorine and carbon. We can see that chlorine will take priority number 1 because of its atomic number. So this will be 1, then this one will be 2, priority number 2. And then we forget about the left hand side, we go to the right hand side. You can see that this will take priority number 1, this will take priority number 2. So one of the things that you should know is that when we have a methyl and ethyl, we have CH2, CH3 and CH3. You should know that this will take priority number 1, this will take priority number 2. Let's say we had a propyl. Propyl will take priority number 1, ethyl priority number 2, methyl priority number 3. So in this case, you can see that we have higher, higher, and lower, lower. So this will be Z. It's a Zusamen. So we start by writing Z, and then we put hyphen. Alphabetically, we have 2 hyphen chloro hyphen 3 hyphen methyl. We can write pent 2E. You should be able to see the priority by looking at the skeletal structure. So in this case, we have our first carbon here, our second carbon here. Or we can say it's carbon number 1 and 2. We know that here we have hydrogen. So we are comparing a methyl and hydrogen. You should know that comparing a methyl and hydrogen, methyl will take the first priority because of the atomic number of carbon. Comparing it with the atomic number of hydrogen. So we have higher, it's actually lower here. Our higher is here. We have lower here. And then we have bromine, comparing it with this carbon here. Remember that here we don't look at bromine, we look at what is connected directly to this carbon here. So here we have carbon, comparing it with bromine. Bromine has higher priority, carbon has low, so this will be Z. Let us look at this one. We know that according to skeletal structures, we have hydrogens here. So the name for this, we start with the IUPAC. We have 1, 2, 3, 4. It's actually 3. 2 carbons, because this bond is moving to chlorine. It's a bond between chlorine and carbon. Let me actually draw this in a more accurate acceptable structure. So it should be like this. Then we put it out bond here. The lines should not be longer than the ones that has carbon and carbon. So in this case we have 1, 2 carbons. Then we know that we have hydrogens here. Then this is just the bond between chlorine and carbon. So we have ethene. We cannot really show the position of ethene because this is the only position it can be, the double bond. And then on carbon number 1 we have chlorine, and also on carbon number 2 we have chlorine, so it's dichloro. So you can combine the names. We have 1,2 hyphen dichloro ethene. Then we can put a hyphen here. You can see that this is a zoosamen, so we put Z here. One would also say this is a cis 1,2 dichloroethene. So it is possible for a compound to be a Z and also be a cis. In the next lesson video, we'll be looking at more examples for the practice purposes. That's it for this lesson video. This is Wahula SJ. Thank you very much.